So now that we've had a brief introduction to what functions look like when we look at the graphs of them, let's now look a little bit at function notation. And again, this is just an introduction. You're going to go into a lot more detail when you hit college algebra. This is just an introduction. Let's take a look at function notation. If something's a function, we're going to use a symbol f of x. F of x is just special notation. It essentially is a fancy way of saying y. X is going to represent the x value that we're going to plug into the function. F of x will represent the corresponding y value. So again, f of x is just a fancy way to say y. And when you see the word evaluate in your instructions, basically that means plug and chug. So we want to evaluate this function for x equaling -1. All that means is wherever you see an x here, your job is to plug in a -1 to figure out what you get. So let's rewrite this function, but where I see the letter x, I'm going to write the value that they're asking me to evaluate for, which in this case is -1. So f of x equals 2x minus 3. Now it looks like, as here I'm multiplying 2 times -1, it looks like I'm multiplying f times -1. Keep in mind, f of x is its own character. F of x means y value. So the f is not separate from the x, it's one unit. And so I'm just going to keep writing f of -1. It's not the same thing as saying -f. So I'm not multiplying. This says f of -1 and it's just its own special symbol. But I will go ahead and do some arithmetic on this side, and I'm going to multiply before I subtract. 2 times -1 is -2. And -2 minus 3 will tell me that f of -1 equals -5. What the heck does that mean? Well, here's what it means. Again, x is the y value we plugged in. They told us x was -1, so we went ahead and plugged it in, and then we cranked it out. F of x, in this case f of -1, it's the corresponding y value. So what this is telling me is when x equals -1 in this function, when x equals -1, y equals -5. And that also would imply that a point on this picture, a point on this function, would be -1, -5. That ordered pair exists. For x equaling -1, we found that y, which we called fancily f of -1, y equaled -5. Let's try another example. Let's keep that same function, but this time let's change the x value and see what we get. So instead of x being -1, let's look at x being +5. And again, if they're asking me to evaluate, they are asking me to plug and chug. So I will look at f of, instead of using the letters x, I'm going to use the number 5. So f of 5 equals 2 times 5 minus 3. Again, this is not the same thing as saying f times 5. This does say 2 times 5, so it's a little bit tricky. It's just going to be a matter of getting used to seeing that f symbol. This means the value of y when x is 5. So, the value of y when x is 5, we can find by doing this arithmetic here. So again, multiply before you subtract. 2 times 5 is 10. And then 10 minus 3 will tell us that f of 5 is 7. So again, in terms of what that means, it means when x equals 5 in this function, we now know that y is going to equal 7. So when we plug in a value of 5 for x and crank it out, we get that f of 5, or that y value that corresponds, is now 7. And so a point on this graph would be the x value 5 paired with the y value 7. So there's an ordered pair on that graph. Let's look at another example with this time a different function. Let's do a different function this time. Let's look at the function negative 4x plus 7. And let's first look where x is 3. Again, it's just plugging and chugging. I think the hardest part here is to remember that f of 3 does not mean f times 3. That's going to be the hardest thing for us, the hardest habit to form. But we are plugging in a 3 everywhere we see an x. The left side is going to stay put. It's still going to say f of 3, which is a fancy way of saying the corresponding y value when x is specifically 3. So negative 4 times 3 gives us negative 12. Negative 12 plus 7 tells us that f of 3 is negative 5. And so again, looking at what does that mean? This is telling us that in this particular function, in this equation, when x is 3, we now know that y will be negative 5. And so if we were to graph this function, then a point on that graph would be the coordinates 3 comma negative 5, where x is 3 and y is negative 5. That'll be a point on that graph. So let's take that same function one more time, this time doing a different x value. So this time let's try an x value of 0. Again, we are plugging and chugging. So we're going to look at f of 0 equals negative 4 times 0 plus 7. So everywhere there was an x, I put a 0 instead. Again, the hardest thing to remember is f of 0 does not mean f times 0. This does not say 0 on the left. It is f of 0, which again is just a fancy way to say here's the y value when x is 0. So negative 4 times 0 is 0. And then for 0 plus 7, we find that f of 0 is 7. Again, what does that mean? It means that for this particular function, in this particular graph, when x is 0, then y is 7. And so again, if I drew this picture, a point on that graph would be 0 comma 7. Let's take a look at one more couple of functions where instead of linear functions, we're looking at quadratic, which are a little bit more involved in the plugging and chugging part. Okay, so here's an example where we're taking a quadratic. You'll see that x has an exponent of 2 as its highest degree. We're going to take a quadratic function and do, again, some plugging and chugging. But the fact that this is quadratic just makes the plugging and chugging a little bit more interesting, we'll say. So let's start by plugging things in. Wherever I see x's, I want to put this negative 5. So f of negative 5 equals... And then we need negative 5 squared plus 4 times negative 5 minus 12. So notice that comparing the original function they gave me to my plugged in version, everywhere there was an x, I now have a negative 5. Not only do I have the negative 5, I also have parentheses, and I really want to emphasize that here. Because when I'm looking at negative 5 in parentheses squared, that means negative 5 times negative 5, which is positive 25. If I didn't have parentheses on that, exponents are weak and they only affect what they're touching. Technically, what this actually looks like is negative 1 times 5 squared, or negative 1 times 5, which is negative 25. These are different answers depending on whether I have parentheses or not. So the parentheses are very important. Please try to remember anytime you plug something in, put parentheses around it. So again, this is not f times negative 5, this is f of negative 5. It's going to tell us the y value that pairs up with an x value of negative 5. So now negative 5 squared is negative 5 times negative 5, which is 25. 4 times negative 5 is negative 20, and then I have my minus 12. So I essentially just took care of all my multiplication. Negative 5 times negative 5, and 4 times negative 5. Now I've got a bunch of subtraction. I'm going to go ahead and read that from the left to the right to help me out. So 25 minus 20 would be 5. 5 minus 12 would be negative 7. And so now we're done, and we can say, as far as an interpretation here, when x is negative 5 in this particular function, the paired y is negative 7. And so if I graphed this, I would see a parabola shape that kind of looks like that U shape. And in that parabola, I would see a point on that graph that was negative 5 comma negative 7. That would be a point that existed on that parabola. Let's use the same function, but this time instead of looking at negative 5, let's look at positive 2 for my x value and see what we get. So again, I want to begin by writing down my function, but where there were x values, I am now going to put 2. And again, the key here is we have to remember our parentheses, because in the last example, it would have made a big difference. So out of good habit, every time we plug in a new x value, we'll put that value in parentheses. So in parentheses, I'll have 2 squared plus 4 times 2 minus 12. So again, it matches the function I had, but everywhere there was an x, there's now a 2 in parentheses. So then cranking this out, I've got f of 2 equals 2 squared just means 2 times 2, so that's a 4, plus 4 times 2 is 8, and then minus 12. And then to do the addition and the subtraction, I'm just going to go from the left to the right. 4 plus 8 is 12, and then 12 minus 12 is 0. And so again, to interpret this, we would say that when x is 2, y is 0. And so a point on this parabola would be the ordered pair 2 comma 0. Let's look at one more quadratic. Maybe one that makes it a little bit more tough even, because if we can handle this, we can handle anything. Again, the evaluating piece is really just plugging and chugging. So let's take a look at 2x squared minus 3x minus 5, and let's first begin evaluating where x is negative 1. So I start by my plugging and chugging. I'm going to copy my function, but where there was an x, I am going to put negative 1 in parentheses. And I'll do the same all the way through. So equals 2, and then instead of x, I have parentheses negative 1. Then I have the square minus 3, and then again parentheses negative 1, and then the minus 5. So it should match the original function, but everywhere there was an x, I now have negative 1 in parentheses. So then we'll continue cleaning this up one step at a time. And as these things get more complicated, and here's why I wanted to show this example, we really have to pay attention to our order of operations. So think back to your order of operations. Please excuse my dear Aunt Sally. We have PEMDAS is kind of our acronym that we've used before to describe our order of operations. P stands for parentheses, and really that's any grouping symbol. E is exponents, and as we've seen before, radicals can be expressed using exponents, so exponents includes radicals like square roots. We also have multiplication and division, and technically these are on the same playing field, and we handle whichever one comes first, left to right. And then A is for addition, and S is for subtraction. And these are also on the same playing field where they occur, whoever comes first, left to right. So let's keep these orders of operations in mind as we go through cleaning this up. I don't see any parentheses other than the ones I put in for my substitution. There's nothing to do inside them, so I'll skip that. I do see an exponent. There is a square. That square is weak. It only affects what it's touching. It's only going to impact the -1. It does not have enough power to reach the 2. And so I'm going to handle the square first before I move on to multiplication. So I'm going to leave the 2 there that's eventually going to get multiplied, and I'm just going to handle the exponent. -1 squared is -1 times -1, which is 1. And I'm going to leave everything else for right now. So I handled the exponent. Now I'm going to go to the multiplication or division step. I do see a couple multiplications. Let's go ahead and do those. So 2 times 1 is 2. -3 times -1 is +3. And now at the end I've got the addition and subtraction, which again I handle left to right. So 2 plus 3 gives me 5. And 5 minus 5 gives me 0. And so what this tells me is that for this new function, when x is -1, y is 0, and so a point on this function would be -1 comma 0. Let's look at one more where I keep that same function, but this time I try a different x value to plug in and see how we do with that. This time let's try an x value of 3. So everywhere I see an x, I am going to put a 3 in parentheses instead. So f of 3 equals 2 times 3 squared minus 3 times 3 minus 5. So again, it matches the original function, but where there were x's before, I now have these 3's in parentheses. And now as I crank this out, again, I want to follow the order of operations. First come parentheses. The only parentheses that exist are the ones that I put in there for substitution, but inside there's no math to do, it's just a 3. So I'm going to skip parentheses and move to exponents. I do have this exponent that only affects the 3. We got to be careful that they only affect what they're right up on. So I've got the 2 getting multiplied later on. I have this 3 squared, 3 times 3, which is 9. And I'll just copy the rest for now. So that's just handling the square. 3 squared is 9. Now let's do the multiplication. So f of 3, not f times 3. 2 times 9 is 18. -3 times 3 is -9. And then we have minus 5. And so now it's the addition subtraction step, and we'll go from the left to the right. So 18 minus 9 gives us 9. That minus 5 is 4. And so for this last one, again, one more time saying what this means. This is telling us that for this function, when x equals 3, y equals 4, and so a point or an ordered pair that exists on this graph is 3, 4. So you'll see several examples in the homework where they give you a function, they give you an x to plug in. All they're asking you to do when they're asking you to evaluate is say, what is the y value that pairs up with that x value? So go ahead and give them a try.